Hey everyone, we're about to get started. So yeah, hello everyone. I'm really happy to see all of you here. Wow, it's quite a turnout today. I mean, I think it even exceeded pretty much like what we had last time. So it's really great seeing all of you today here, seeing the Python community continue to grow and continue to gather around at this venue. So yeah, really great to see all of you here today. And yeah, it's amazing, especially considering the heat storm we have going on today. It's like one of the Melbourne's like hottest days I feel today when I went out today, so it's quite something. But regardless, happy to see all of you here, and yeah, we're just gonna kick it off. So to start off with, I'd like to make an acknowledgement. So I'd like to begin today by acknowledging the traditional custodians of the land on which we meet today and pay my respects to the elders past and present. I extend that respect to the Aboriginal and Torres Strait Islanders people here today. And just a few quick housekeeping stuff. So pretty much just want to bring forward a code of conduct. So yeah, our community is dedicated to providing an inclusive environment for everyone, regardless of gender identity and expression, age, sexual orientation, disability, physical appearance, body size, race, ethnicity, religion. And if you want to consult our full code of conduct, you can just go to our GitHub. Basically, just bottom rule is just be respectful and treat everyone else how you want to be treated, basically. So simple as that. And where are we on the web? So we're on a number of platforms. We're on LinkedIn. Pretty much it's MicroPython now, so you can just search up on LinkedIn if you want to follow along with the developments of what we're doing. We are also on Mastodon. We're at MelPy at mastodon.social. And we're also on Slack, which you also saw earlier too with the QR code. So the agenda today that we have will pretty much be just a welcome updates, which we are doing right now. And first talk, we'll have Matt, who's over here, be speaking on who is from Planet Innovation, and we'll be speaking on introduction to MicroPython. At 6:45, we'll grab a new drink, meet someone new, and get ready for our last talk of the night. And after that, we have Paridhi, who will be talking about integrating Python and Rust to build better generative AI models. And after that, doors will close at 8. So, of course, all of this couldn't have been made possible without our sponsors, Judo Bank, for providing us this beautiful venue that we are able to meet on today, and AWS for sponsoring us all the food. And I'd like to just firstly hand over to Michael to say a few words for Judo Bank.
Oh yeah, thank you. I see quite a few number of familiar faces here and some new faces. So if you don't know what Judo Bank is a bank that works in the SME space, trying to bring back the craft relationship banking going back to the 80s. Why are we here with Python? We use Python heavily here in Judo's backend systems and data. We use a lot of lambdas to do a lot of cool stuff that I'd love to tell you about. Just a couple of housekeeping things here. If you're wanting the toilets, all the way down past the elevators, go right through the door, take the second door on your right, and it's an all-gendered bathroom in there. Should we need to evacuate this building, we've got fire warden here on staff here. We'll be going to the right of the caged area around there and following directions to go downstairs.
Thank you, Michael. And of course, again, another acknowledgement to AWS as well. We have Alex and Dean over there too, our great folks from AWS who have been able to sponsor us the food and drinks. So we're really grateful for that. And as for our organizers, we have me, Rinaldi, and over there we have Thais. So yeah, there's pretty much just a brief look into our organizers. And we'd just like to give a quick shout out as well to Programmable. Pretty much it's a Australian Software Engineering Conference. If you've heard of it, pretty much it happens in Melbourne every year. And last meetup, we were giving away 2 tickets. And today we're basically going to be giving away 3 tickets, basically 3 lucky members. And yeah, pretty much we're going to be walking through that process as well in a bit too. And pretty much, yeah, we're going to talk about that more later on towards the middle and end of the meetup as well. So yeah, just a bit of a look into as well that they have technical tracks basically based on that.
Sorry, just quickly. Thank you. With the raffle for the tickets, last time around we had a QR code. Today we don't. So we're going to improvise, and obviously this is going to sort of play to my advantage, but I'm just going to ask everyone to come and talk to me and scan my LinkedIn QR code. And if you just type in a message saying Python, I'm going to know that you're looking to enter the raffle. Then I'm going to get all the names, and I'm going to spin the wheel at the end of the night. Sorry, just one of those days. Couldn't get a QR code, but that's it. Just come and see me. Thank you.
Thanks, Dice. So, as usual, just a quick slide as well on what's coming up. So, we're pretty much going to continue on creating a diverse mix for all of you of a mixture of introductory and more intermediate and advanced talks, because I'm sure that everyone here is from different backgrounds. I've talked to quite a number of you, and some of you pretty much are just transitioning into the field of Python. Some of you are already practitioners within the field, already advanced. So we're going to try to give all of you something for everyone. So we're going to try to curate a schedule that can really benefit everyone, no matter if you are a beginner or if you're already an advanced practitioner. And we're going to continue doing that from just having the normal 2-session talks each time. We're just going to try to keep getting a mix of that within the different talks that we'll have, sessions. And yeah, of course, we're going to aim towards having consistent monthly meetups. Also, pretty much just some stuff as well that we are still talking about potentially, as well as a hackathon that's not been confirmed yet. We're still looking into it. And of course, yeah, we're always continuing to look into what you actually want to hear about. So if you have anything that you actually want to hear about particularly, you have any suggestions for improving the meetup, or you want to see anything in particular, come talk to Thais and me. We're always happy to hear your guys' thoughts and look into better ways of improving the meetup for the Python community over here. And of course, just a small slide on getting involved as well. So pretty much just standard stuff. If you are interested in getting involved, talk to me and Thais. We have a number of ways you can get involved, which include being able to get for example, sponsored meetup. If you are interested in sponsoring in any certain shape or form, feel free to talk to us. We can definitely walk you through the process. Aside from that, if you're interested in volunteering, feel free to talk to us as well. We're always looking for more volunteers to help us organize these events. As you can see, pretty much from these kinds of events, it definitely takes up quite a bit, and we're always very thankful for volunteers for taking their time to be able to put this together as well and help us with the logistics of the event. So we're always very thankful for being able to have volunteers helping us throughout the process. And that is really it for me. And now, and of course, if you're interested in speaking, always, feel free to reach out to us as well, and we'll also guide you through the process too. And one of the easiest ways you can also get in touch with us is with the Slack earlier too. So we're always on Slack, so yeah, feel free to reach out to us on Slack. Don't have the Slack QR code anymore right now, but yeah, if you're interested in getting into it again, I'm going to show it towards the end again for you guys to scan in, or you can just approach either of us to get into the Slack too. So without further ado, I'm just going to transition now into our first speaker, Matt. So just before I hand over to Matt, I'd just like to introduce him. So Matt is a software engineer with 25 years of experience across most of the software stack and many domains. He's currently employed at PK Planet Innovation, where, amongst other technologies, MicroPython used to develop medical devices. So over to you, Matt, and everyone, let's please give Matt a round of applause.
Thank you. Thanks, everyone. That's great. So, MicroPython. Well, first of all, I'll start with me. That was a pretty good introduction. 25 years experience just makes me feel old. It's unfortunately true. I guess I've been exposed to most areas of software development, from desktop to cloud to low-level embedded. I've been very fortunate to sort of play around the whole software stack during my career. And I've worked in a bunch of domains as well, which has been very fortunate. But often I've worked closely with the hardware. I originally did a double degree in computer science and digital systems engineering, so they always kind of threw me close to the hardware because at least I had some idea what was going on. Over time, though, I guess I got a little bit jaded with the embedded space, and that was mostly because the development space there really hadn't evolved very much. So saw a lot of evolution in terms of software processes and practices and tooling, higher level languages, all across the software domain, except in embedded. And so it was getting pretty tedious developing in low-level C on these little devices, which is kind of the way it had been since the 70s. So I was getting a little bit jaded, and I was kind of looking out for different interesting sort of things. And that's when MicroPython came along. We'll talk about that in a bit more detail. But it is worth noting that I'm using MicroPython commercially. It's kind of a fledgling language in the commercial space, but we're using it to good effect with the company I work for. Needless to say, I'm an enthusiast. I contribute code and documentation. I've also presented at PyCon AU, so if you really want can we go have a look at some of the presentations that are available? And I also host the Melbourne MicroPython Meetup, which is a monthly event. So, I said before, I've played across a whole bunch of domains. Some people would call that full stack. When I looked up full stack, it said building both the front end and the back end of a website, which just seemed like tip of the iceberg to me. So I tend to play in the lower part of that iceberg most of the time. Meetup, I alluded to the QR code there, and scan it right now with the links. But it's a monthly meetup for all things MicroPython. It's hosted at the Hackerspace in Hawthorne, which is a really cool place if you're interested in building stuff. There's like lathes and 3D printers and laser cutters and all sorts of things you can really help yourself with. Our recordings are published on the MicroPython official YouTube channel. We usually have a newsletter up as well. Yeah, that's always welcome. Just want to get some hands up so this audience participation. First of all, use humour here, just so good people can raise their hands. And look, I give these kinds of talks a lot of early groups, and you'd be surprised that not everyone puts their hands up. They don't all necessarily identify as human. Thank you for that. Who knows what a microcontroller is? This will help with my explanation. Some good, okay. Has anyone here written software for a microcontroller? Okay, that's good. Don't be afraid if you haven't. Cover it. And who knows what MicroPython is? I've just been battling a word again. Okay, it's a couple. Okay, so what's a microcontroller? In essence, it's a small computer. It's one of these things. I bought a bunch of things you can play with today. I'll hold up the Q's once, a little Lego guy with a little microcontroller on his chest. They're effectively like a little PC. You can think of them like a little PC. They've just got a lot less resources. Typically kilobytes of memory, hundreds of kilobytes of flash perhaps. They're usually designed to work on small tasks where it's important to do things in a timely fashion and be ultra reliable. It's also, they're very cheap. You've got a lot of microcontrollers. In fact, I would be surprised if you looked in this room, there would be a few thousand microcontrollers. Your phones would probably have dozens. I've got enough to you all bring home. So yeah, there's plenty here. They're going to have predictable behavior as well. So when you write code for a microcontroller, unlike a PC, there's a lot of things running at the same time. Microcontroller, it's just like one little task. You want to light LEDs when a button's pushed, or you want to connect to Wi-Fi and make an MQTT packet connection. So small, targeted sort of applications. And it's often easy to think about the car, because cars are rife with microcontrollers. There's often dozens of, most cars these days have dozens of hundreds, or even thousands of most modern vehicles. It also means, just quickly, that the market size is really big. It's projected to be 50 billion in a few years, and they sell something like 30 billion units a year of these little microcontrollers, so it's really large and it's kind of under the radar. So it's interesting talking to a Python user group here who are sort of working at a different level, and these things are just pervasive, and something you may not have come across. what's MicroPython? So this was actually on a Reddit channel. People have strong opinions in the embedded space, and you get a lot of grey beards who are really reluctant to pick up something different. And so this was a comment which was thankfully deleted afterwards. They have strong opinions. So what is it really? It's an implementation of Python 3. It's always been Python 3 for microcontrollers, but it's been rewritten to have careful consideration of resource use, because the defining difference here these things versus a computer is the lack of memory and the lack of storage space. So yeah, you need to be really careful about how you use those resources. So yeah, written in C, no code's been reused from C Python. The creator, I'll talk about him in a moment, effectively looked at the documentation and said, okay, let's use that as a guideline, and wrote everything you needed to from that. Started as Python 3.4. We're still playing 3.4 as a base, but the reality is we've got features from much newer versions as well, async and more something. It's been difficult to say we're any higher than that because there's features that we haven't been able to implement, mostly because they take too much memory. Is the main reason. So where we've been able to add features, we have, and so we're always looking to add more and more features to MicroPython to improve that developer experience, or to make it easier to port regular Python libraries to it. We just need to be very cognizant of the fact that we're working in a very restricted set of environment in terms of resources. But there is excellent support for Python, the language, comprehensions, generators, all that kind of stuff you're used to using. You will find in MicroPython for the most part. We've got F-strings. It feels like a very modern sort of development environment. It's a similar experience to what we call Big Python. And there's exceptional test coverage of the language. There's tons of tests which actually thresh out the language pretty well, so we're usually pretty confident that the language itself is working well. The standard library is a bit harder. It's, as you all know, it's really big, and it's really hard to get all of those libraries written and working on such small devices. So lots of the standard library is implemented, but certainly far from all. And it's a similar story for third-party libraries that might be used to in Python. You can't just IPI or pip install anything and have it expect to work. Numpy's not going to work out of the box. Pan's not going to work out of the box. They take way more memory than all of these devices can run. So, we have got equivalents for those, but they're all designed around those limitations. So some libraries are built into the firmware of MicroPython, and some you can grab from a MicroPython lib, which is a separate repository with other parts of the standard library. I can talk about what that will be later. And we also keep track of the status of various libraries. In addition to all the stuff that you guys will be familiar with, we've also got the machine module. This is a module which is at the heart of the embedded development here. So most of the time with microcontrollers, you want to interact with things. You want to make pins go on and off, you want to light LEDs, you want to talk to temperature sensors, all that kind of stuff. And those acronyms there, which might not be that familiar to you, are all the kind of technologies that you need to connect to those devices. And MicroPython makes it very Pythonic, very easy to connect to these things and control those devices. So very really quick example. Picture is here where you've got an LED with a resistor and a microcontroller. You just import a pin. In this case, the pin is numbered 0, and we're making an output pin. We're going to turn it off, and we're going to turn it on. And that's all you need to do to toggle the pin in MicroPython. The PWM example is a little bit more complex if you're not familiar with PWM. It stands for pulse width modulation. It basically turns a pin on and off rapidly, such that you can deliver power more or less to that pin. It's where we get dimmer and lighter LEDs. So in that case, then we're using 20% of the G, which is 100, so 20% brightness and then 90% brightness. So these are all just single line commands to do what, if you were to do that in the embedded space with C, would usually require a fairly tricky compile, deploy, try it out, sort of cycle. That's nice, thank you.
Right. There's always one, every meetup, leaned against the wall.
I'll save this a little bit. A brief history of MicroPython started a bit over 10 years ago. And I guess the person who started was trying to figure out if Python was even possible on a microcontroller. Turns out it was. At the time, there was a bunch of money being thrown around at Arduino projects, and he thought he wanted a piece of that. So MicroPython became a Kickstarter project. That was successful. Produced a bunch of boards, and then pretty quickly it kind of snowballed. And the European Space Agency got in touch because they wanted to use it in space. The BBC Microbit was being given out to all of the UK Year 7 students from memory, and MicroPython was deployed on the BBC Microbit. And then it's just kind of snowballed again further and further. We've got many more different microcontrollers. It's been discussed at PyCons, these conferences. It's been used in 20 or 30 badges now at various conferences. There's professional projects which are selling devices running MicroPython now. And more recently, there's a WASM port which has enabled PyScript to use as well. I'll mention that briefly. The core team is led by this guy, Damien George, and a lot of people don't know, he's Melbourne born. So MicroPython, we've got a close association here because it's built out of Melbourne. Now, at the time when I reached out to Damien, he was working in Cambridge in his postdoctoral work. He's a theoretical physicist, but decided to get microcontrollers. He's going to put that over here, I'm sure. He's moved to Geelong, so I'm not sure we can completely claim that it's Melbourne still, but yeah, it's in the same state at least. There's really only 3 people who work on this who are dedicated to it, and Jim and Angus do it part-time as well, so it's a very small core team. And then there's sort of an outer ring of people who care, and then as a lot of open source projects, there's a small army of other people who contribute. So I guess why MicroPython, I've alluded to this before, but I guess a lot of you will be sort of familiar with this. Like, why would you guys code in C or C++? If you had the opportunity, you would use Python probably most days of the week, I would hope. It's readable, it's easy to learn to use. It's easy to test. That's a big deal in the embedded space, where the compiled languages can be quite difficult to test. It's very flexible, there's lots of libraries out there. But the main benefit for me when I'm saying to my bosses in the embedded domain is 30%. Right? It takes roughly 30% less development time compared to those languages. At least that's what I've observed. I'm not sure that's an exact sort of figure, but I've definitely noticed that our customers are happier when we're using it because we can move quicker and we can save them money. It does depend on the project, but that 20 or 30% is certainly in the ballpark. We've run a few projects with MicroPython now. All of them track roughly to our estimates, and we've done enough C++ projects that we're pretty confident that we're coming in that sort of reduction of effort. Now, of course, that's just software effort. You know, anytime you deliver a product, there's a lot more to it than that. So software effort might be a small component, but in a lot of our projects, it's quite significant. I also expect that number to increase because MicroPython is maturing and the tools getting better all the time. So, how those, anyway, by the way, if you've got questions, put your hand up and you can yell. I'm not fragile on that, you know, I think I'm talking. How those improvements are achieved, I guess we'll talk about that, but it's mostly because, at least predominantly for you guys, to be aware that it's a high level language that's more rapidly developed, which is often. But the real key one for me is having the live REPL. So you're all familiar with having a REPL in Python. We've got that in MicroPython too. It looks very similar, looks like what you would expect. The difference for us is that it's actually running on the device. So we'll establish a serial connection, typically over USB, to these devices. And then we can interact with those devices through the REPL in a live fashion. So if I want to toggle those pins, if I want to set that PWM, if I want to talk to those temperature sensors, I can do that in a way that's completely interactive. It'll be very familiar to you folks, but to an embedded developer who's used to that build, compile, deploy cycle, it feels a bit like magic to you folks. So it's really hard to overstate the benefit of having that live REPL. It's a real game changer. Especially when you're developing like a driver to interact with a peripheral. I can just poke that driver and see what it's giving me back. I can explore and experiment with it. So for me, that's really wonderful. The Unix port, there's a build of MicroPython that runs on Unix, but it's the same kernel, it's the same technology, it's the same code that runs on the devices. It's just a lot faster to run. You can configure memory so it behaves like one of these devices, so you can use your rules of memory on the PC. It turns out this is really useful for unit testing in particular. So as a first stage, we offer unit testing in the Unix port. You can access the host file system, you can run through unit tests really quickly. Fantastic for CI pipelines. There is no machine module, which I alluded to before about talking pins and stuff. We mock that out, so we've got a whole bunch of libraries to do that. But that is a significant difference. And we also use hardware in the loop testing, which I'll cover another day perhaps. It's also published as a Docker container, so one thing you can go do when you get home, if you like, you can go run that Docker command and you get your MicroPython prompt, and you can interact with it very easily. We also use that a lot for testing and just for experimentation. Another benefit is MP Remote, which is the tool to interact with MicroPython devices. So just pip-x install it. Works on all major platforms. It's a Python application in its own right. It allows you to connect with a serial connection, which you can do with any serial tool, if you like. But it also lets you interact with the device on other levels. With MicroPython, you've got a file system on the device, so you can put files, Python files, onto that device. You can copy data files off it. You can execute commands on the device from your PC. You can do package management, so I'll cover that in a second. And you can also do mount. And for me, MP Remote Mount is one of those superpowers, which allows you to mount your file system from your PC as if it's on the device. This is pretty amazing. So I think I've got a quick example. So at the top here, I've just got an example where I'm doing a directory of malware of my local computer. I've got 4 files there. Then I MP Remote mount the current directory. And then what I'm looking at here is this is the MicroPython prompt that's making a connection to my device. I'm looking at the prompt as it's running on one of those devices. And you see that if I do an OS list, MP Remote has mounted my PC's file system on the device, so the device just thinks those files are on it. And this is wonderful because you can do all of your regular GitHub commits and whatnot on your PC, and then you can just mount onto your device and just test your code that you're working on. So yeah, for me this is a real game changer as well. Turns out they can really iterate very rapidly like this. MIP. Okay, so MIP is like pip, inspired by pip. MIP installs packages, that's what it stands for. I think that the acronym came after the name, to be perfectly honest. It's simpler than pip. It's still early days. We don't have the ability to specify a bunch of things to install. But you can install things from MicroPython lib or GitHub. It's a single line to MIP install. On a device that has Wi-Fi, which perhaps a quarter of these devices actually you can put it on the internet directly, you can MIP install directly on the device. Alternatively, you can use MP Remote to say, MP Remote, install this package on the device that's connected. It's as simple as that. We can also use precompiled code. So just like Python has PyC files, MicroPython has MPy files. So normally when you run a Python file, import a Python file on a device, it actually goes through the process of compiling it locally in the bytecode and then executing it. When you install the package, instead of actually installing just the .py file, MIP can install the precompiled MPy file, which uses less space on the device and avoids the whole compile step on the device. So a little bit faster. So this is just one I did earlier today, and also show you it runs on Windows. So installing AI REPL, which is async and AD REPL, which is another talk for another day. But it's just as simple as that. Just install that file. This other example here is actually just showing how you can install a specific file from on the device as well. Really easy stuff. Okay, so non-technical MicroPython benefits. This is just some observations that I've seen also from running projects and serious projects at work. Junior development is like it's supercharged because if you've ever had to work with juniors on an embedded C project, the ramp up is extraordinary. There's so much to learn. There's a long time before they can really be contributing. What we found with MicroPython is usually they're coming from some experience with Python. And as long as you've got some experienced MicroPython developer and really embedded developers to guide them so they don't abuse the amount of memory and flash resources that we have, they can ramp up really quickly. We've had like huge contributions from junior developers in a really rapid time. So that's massive benefit that we hadn't really expected. Also found that we've been able to be really responsive to customer requests. We've been on client meetings where the client has wanted to do things like change an algorithm, and we've literally been able to do it while they're connected against the Unix port or even the device that's connected. And that kind of thing, for me, has not been very possible in the embedded space before. Customers love having that level of interaction. They love being able to sort of contribute at that level. And this last point is something that's a bit hard for me to describe, but I've also found that when I'm developing in C and C++, I spend a lot of time thinking about the details of how to develop what I need to develop. So you sort of get really bogged down with where is this bit of memory going to go? How am I going to do this? What kind of data structure am I going to use here? You've really got to think quite a lot about how the solution is going to be implemented. Whereas I find with MicroPython, you're working at a higher level, and the solution, the problem that you're trying to solve, becomes the key thing that you spend time thinking about. And for me, that's been a real productivity boost. Cool stuff that I didn't know where to put anywhere else. I'm not sure if I've got time to show these, might be another time, but Walkly is a wonderful tool. It's an in-browser simulator for embedded devices. If I can bring it up, I'll bring it up later, but it's something you can go try yourselves. It also has MicroPython support, so in the browser you can simulate a microcontroller, you can connect peripherals to it, you can wire them up in a sort of a very graphical sort of way, and you can write code to explore those peripherals. And PyScript I want to mention as well, because you're probably actually used to with PyScript a little bit. So PyScript is an effort supported by the Anaconda folks to get Python running in the browser. It's based on all the Pyodide work. So they actually download Python to the browser, and then you can write Python applications to interact with the DOM in the browser. They've also integrated MicroPython for that, because the MicroPython build is so much smaller. So MicroPython you can target with WASM as well. If this doesn't make sense to you, don't worry, you can go through that later. But the whole point is here that MicroPython's a heck of a lot smaller than regular Python, 11 meg versus 300K, and that directly translates into load times in the browser. And so there's a lot of people very excited about the potential for using MicroPython, or rather, the potential for using Python via MicroPython in the browser. Concerns? Actually, no, I'm running out of time. Some of the concerns are you need a more powerful micro, memory fragmentation. Those things there. We'll cover them in a little bit more detail. Compared to C, you do need a more powerful micro. Flash and RAM are kind of the key things where you need a little bit more. But I guess the thing to remember is that microcontrollers these days are still following Moore's law, and they're effectively little supercomputers. So the Raspberry Pi Pico, which some of you may be familiar with, Raspberry Pi released it about 2 years ago. It's a dual-core microcontroller with a couple hundred K of RAM. This is sort of unthinkable 10 years ago. And they're $1. Actually, you can buy one on a board for like $4. And they're a super capable little microcontroller. So yes, MicroPython does use more resources, but we've got so many more resources at our fingertips now. You're better off having that effort being put into improving programming productivity, right? That said, if BOM cost is the key thing, C might be a better fit. Right? Like BOM cost, like if you're trying to save cents in the dollar for a product, you can usually drive C into a much smaller microcontroller, which might cost you cents cheaper. So that's not a space that MicroPython can do. Memory fragmentation is something else we also need to worry about. It's a GC collected language, so we need to be careful about managing that. There's lots of ways we can deal with that, but it's something that should be at the forefront of your mind. You don't want those GC pauses occurring when you're updating displays or doing something that's time critical. Performance, if you want to eke out like every last megahertz, you probably do want to be using C in a compiled language. But the thing that I would usually recommend is developing in MicroPython first. And if you need performance, add a user module. Much like Python, we really drop down into C when we want real performance. Same thing for MicroPython. That's it. Anyway, just like Python, we offload our performance improvements to C. So we can build a C module very easily in MicroPython to do something that's performance critical. And that's just it means you can keep most of your application in MicroPython. usually performance is not as worried. You shouldn't be worried about it as much as people often do. That was terrible English. I apologize. Low power use. Some applications where you use microcontrollers, you really want to be worried about running off a battery. MicroPython has a good story there, but it's not as good as C. So a lot of the time you want to be driving these microcontrollers into sleep and deep sleep modes. It's much like putting your laptop to sleep. The microcontrollers can do it quickly and effectively. So MicroPython allows you to drop into those sleep modes. C does it a little bit more control. And maturity, I mentioned this before, MicroPython's only 10 years old, and it's still evolving pretty rapidly. So the tooling's getting there, the documentation's getting there, but all of it's not as mature as some of these other languages. Really done, running out of time. So the wrap up is that MicroPython is like reinvigorated by enthusiasm for embedded development. No longer jaded, but kind of excited to do this kind of stuff now. And when I have to use C, usually my rule is that I'm doing C to develop MicroPython, which is written in C. I try not to do other C development now, if I can avoid it. It's just also proven to be really good technology, so it's ready for prime time. I think it's really good fun. Yeah, interacting with the real world through these devices is just inherently interesting. And what's next for you folks when you all go away? Come down and play with these things. They're kind of interesting to tangibly feel what these devices are like and what people are doing with them. Check out Lockley, it's a really easy way to sort of play with MicroPython. Buy a device, like I said, they start at about $2. You can get a really good development environment for like $40. And do come along to the MicroPython Meetup if you think this is something you would be interested in. Yeah. There's a bunch of devices that run, all of them run MicroPython, they all do different things. Some of them have displays, some of them are e devices, some of them have cameras. Yeah. Some useful links for you to keep track of. I'll publish these slides so you have access to them. And that is it. The mid-journey image that everyone needs to think through, I think so. Yeah. I'm going for time. Cool. Next MicroPython meetup is next week, next Wednesday. Yeah. I'll also, there's a link at the start of these slides. You'll be able to find where the meetup link is.
Thank you for your talk. I just have a question. Can you just elaborate a little bit on what does it compile to? You mentioned the bytecode similar to Python bytecode. I'm curious, how does that run, or is it just running on some specific supported devices?
Right, so it's got the same architecture as Python, and by that I mean you have that compile step to bytecode, and then you run it through a bytecode interpreter. But the bytecode is different, so you can't run MicroPython bytecode through CPython's interpreter and vice versa. But the interpreter is actually running on the device. So it's a C application that's running on these devices, as well as the compiler. The compiler runs there, but it's like a front end to the interpreter, if that makes sense.
Yeah. Thank you.
Anyone else? Yeah.
Hi, thanks for the talk too. Is it still about, is it still possible to use the makefile and nicofile that you could use usually in embedded systems with Python?
Yeah, absolutely. So MicroPython is built in C. So depending on which, MicroPython, the interpreter and the compiler that I just mentioned, is very platform agnostic C. But there's also a whole part of MicroPython which is port specific, and by that, when we're talking about interacting with pins or PWM or those kinds of microcontroller specific technologies, that depends on which microcontroller you're using. So all of that's built on top of Expressive's APIs or STM32's APIs or so on. So there's a whole bunch of code that's specific to those microcontrollers. Right? At some point, we have a makefile which builds a variant of MicroPython which you deploy to the specific microcontroller you've got, and you can hook into that and build your own like C extensions to replace it. Is that okay?
Thank you very much. I have another question. Like you mentioned, for example, STM32, and it can also save time to just use the generative code for peripheral, on the STM32. But I guess the application for the MicroPython would be more about state machines and all this kind of stuff.
Yeah, that's right. I mean, MicroPython kind of takes over your microcontroller, and then you work into the MicroPython environment on the STM32 board. But you can build, like I said, you can build a C module that runs alongside it. So, I can take you through that if you like.
Thank you very much.
For the REPL environment, is it only in the dev context, or can you have REPL, like a REPL-like environment running in prod context as well?
Is it like a production environment?
Yeah.
Yeah, we do that. It depends on your needs, but there's no reason you can't have a REPL environment in the production environment. We often use it for like the manufacturing phase. So just today, I was using the async IO REPL, which allows you to do coroutines in MicroPython, and it does that in the REPL. But we have like a heater controller, right? So we tell the heater controller to go to 40 degrees, and as it's going, we can actually tweak the PID values for the PID loop while it's running. So yeah, that's been really fascinating to use, and something that our systems engineers love because they can do everything live.
Cool, thank you.
Hey, it's Jess. Jess was actually doing that today, so you can speak to Jess about how that works for her. She's a MicroPython user as of a few days.
4 days, I reckon, yeah.
Sorry, I didn't mean to put you on the spot.
What's it like using, say, multiprocessing or real-time constraints on microcontrollers with MicroPython?
Good question, and there's no simple answer. Well, I guess the first thing to say is we don't have multiprocessing support. We do have low-level, like the underscore thread library is implemented on devices that actually have multiple cores or are running real-time operating systems. So if you know microcontrollers, the ESP32, the STM32, and the Raspberry Pi Pico all support some concurrency. It's still, there's a lot of constraints for that is a short answer. We're looking at using OpenAMP to do some multiprocessing stuff on these little devices, which kind of blows my mind when you're looking at a $4 device and trying to do multi-threading stuff on it. A lot more detail I can cover, ask me to have a look up here and have a chat. Although I should say, like, yeah, real-time stuff is an important thing in the microcontroller space, and you do have to be careful. Like, running in the interpreter, you have less guarantees about those real-time constraints, and often a lot of those times you really want to offload that to C. So, yeah, that's not like a fixed thing. MicroPython allows you to hook into interrupts as well. So, yeah, talking more about that.
Just in the context of that same question, does it have a global interpreter lock?
It's, again, not a simple answer, but most of the time it does. On the Raspberry Pi Pico, it doesn't. And that's to get you the extra multi-threaded performance. So it's basically a compile time option, depending on which micro you're looking for.
Okay, is that it? Anyone else? Well, I'm sure you can catch up with Matt later to ask all of the questions that you might have. Thanks, Matt. That was lovely.
So now we'll take a quick break and pretty much get some time to mingle a bit, get to know more people, and we'll reconvene again in 15 minutes. But just a quick note before the break. We're gonna switch up the way that you can enter the raffle to make it easier for all of you. So pretty much now you can go into our Slack. So if you're a member, feel free to pretty much just go into the Slack and search for the channel February-raffle. If you're not on the Slack, I'm gonna put up the QR code for join the Slack right now. You can join the Slack, and pretty much all you need to do is join the channel February-raffle and just put just any message, very much just saying that you want to join the raffle, like, yeah, like I'm here, or like, yeah, I want to join the raffle, anything basically. As long as you put a message in the channel for the rest of the meetup, then you'll be counted in the raffle. So I'm going to put up the, if you don't have the channel, if you don't have the Slack yet, if you're not on the Slack channel yet, I'm going to put it up, and so you can join that's all for now. And yeah, we'll see you guys in 15 minutes. All right, so we're gonna have our second speaker for tonight. We'll be talking about Python, Rust, and generative AI. And our speaker tonight is Paridhi. So just a bit about Paridhi. Paridhi is an experienced professional with over 15 years of machine learning and software engineering. She has experience in building and deploying end-to-end statistical and machine learning models in large enterprise environments in e-commerce, retail, and banking. Her expertise lies in software engineering, machine learning engineering, ML production systems, and emerging ML ops technologies. She holds a master's degree in machine learning from University of Edinburgh, Scotland. Please join me in welcoming Paridhi.
First of all, great talk, Matt. My name is Paridhi. I work as a principal machine learning engineer at Breast Farmers Fund Digital, and I'm very happy to be here today to present my talk on Python, Rust, and generative AI. So I've been in this industry for over 15 years. When I started way back, it was all about C and C++. There was very little Python that was being developed. And so my initial experience in software engineering was around low-level languages. So how do you work more closely with compilers? How do you do better memory management? Sort of things like that. Then in the next few years, what would happen is Java, Python, and high-level languages like these, they became increasingly more popular, and for very good reasons. And over the last few years, these are the languages that are more mainstream, just given that the kind of projects that run everywhere worldwide are mostly at application level. So if you're building a website, if you're doing other things, you are working on the front-end programming, you would never need to go to low-level coding or low-level talking to compilers and doing things like that. And Python in particular it can be said that it is one of the most popular languages throughout the world. There is amazing user base for Python. Python is first and foremost language that a person picks up when they start a machine learning project. Python is also the first choice for MLOps. And so far today, apart from other languages like R, and there are some other contenders as well, Python remains the most popular choice for machine learning. Having said that, there are a few newcomers also in this space, and that's what my talk is going to be about today. So there's a language which is called Rust, and in this era of generative AI, when people and teams are starting to build generative AI applications, they are either training their own LLM models, or they are just taking off-the-shelf LLM models and working on them to create their own software. There's a question of what languages should they go for and why. So the agenda for today's talk. So I'll start with Python, ML, and Gen AI. So what are the good bits of Python? Why Python has been in this industry for so long and still is. Then I'll talk about Python's performance in the last 20 years, and has it been? So that's the main question. Then I'll just introduce Rust briefly, and then I'll talk a bit about, is Rust good enough to supersede Python in machine learning and Gen AI space? Then I'll briefly talk about MLOps and how Python is currently used in MLOps. And then I'll do a comparison of how the same thing can be done using Rust. Then I'll move on to a quick example for building a lyrics classifier using Rust. So that will be an example of how Rust can be implemented for a Gen AI application. And then finally, the possibilities of using, creating Gen AI application using Python and Rust together. So it's not like we have a choice of either using Python or Rust, but there are possibilities of using them together. So let's start. Python is widely used in AI and ML. Early days of artificial intelligence and machine learning, everyone was on Python. Go. Not exactly, like a lot of academic researchers, they also started with R and remain on R. But as these machine learning projects, they move to production, people mostly abandon R and they move to Python. So what are the reasons? Very rich ecosystem that has built slowly and progressively in Python. So all the popular libraries that you name, TensorFlow, PyTorch, Keras, they are written in Python. Python has got an amazing developer community, and that is also the reason that these libraries, they are very strong. They have a very strong user base, and if somebody today wants to learn machine learning, they would just go and first learn Python to learn machine learning. Python also is very simple and readable. Now, when Python was invented, and this was way back in the early 1980s by Guido and Russell, at that time, C, C++, and other languages, they were fairly mature, but they had their own set of problems. So I remember, like, when I used to work in them, it was, problems like static typing that used to go wrong, difficult memory management, memory leakage issues. There was multi-threaded programming that was at your disposal, but that was very difficult to write. The programming was difficult. And when Python came along, it was so easy. C++ errors, syntax errors, runtime errors, they would all go away. Python was a beautiful language. And readability, of course. So readability of Python, way, way better if you compare it to C++. Like I said, strong community support from Python, interoperability and flexibility. So that was also one of the very good things about Python when people switched from C++ to Python. It was very flexible. So if you look at the integration that these external systems and tools have with Python, they far supersede that of any other competing language. Similarly, if you look at the research side of it, the machine learning scientists, data scientists, professors in colleges, when they would be doing their research, their choice of language would be Python mostly. Another good thing about Python, which is very good for machine learning today, is the API documentation, and this is not talked about as much. The API documentation, if you pick up any of the libraries and external software that you might want to integrate in your own software, there is very, very good API documentation generally available. And the last is around teaching. So Python is also a very good choice for online course that you can do. So that's massive open online course, right? So that can be, I'm talking about Coursera, Udemy, Udacity, and things like that. So Python is also the choice of language for that because it's easy to teach Python. So those are the good things about Python and how Python and why it was chosen for general machine learning applications and is still the choice for Gen AI. Now, looking at the next slide, Python's performance over the last 20 years, has it peaked? So there's a lot of talk, and this is generally how languages, they follow their pattern over the years, from when they are invented, created, and how they are eventually adopted in mainstream industry. So on your y-axis, you see the language features, right? So as you build more and more features in a language, it becomes more versatile at the cost of becoming more complex for your adoption. On the x-axis, you see projects built. So this is about how many companies are using a particular language and how many people and developers are using that. And in the center, you see an orange vertical line and a blue horizontal line, right? So those represent the diminishing returns. So that's the point, and the big red curve that you see is how is the expected trajectory of Python. So, like I said, Python invented in 1980s. It's been 44 years now. So you can expect, and this is the natural course, right? So you would expect that there would be newer languages that would now are expected to supersede Python. And some of the key criteria in which they will do is the one that is shown on the blue horizontal line, is around threading, performance, and packaging. So packaging is a big one. Now about Rust. So Rust is more low level than Python. Rust was created by a Mozilla employee in 2006, but They didn't make it public till 2010, so it's like 14 odd years. Um, so some of the key concepts in Rust is it has a structure which is called the cargo project structure. So it comes inherently with that. And I'll talk a little how it compares with the virtual environment and how having a simplified project structure inside a virtual environment can benefit Python developers like yourselves. The next one is around the concept, and this is a new concept of ownership and borrowing. So memory management and memory safety are today very big factors for choosing a programming language, and also for writing your application, right? And though Python has done a very good job in doing so, there are better choices available right now. There's still a lot of problems with Python's memory management. So memory safety is a term that is used for even if you are given tools to manage your own memory, and if you don't do that well, right, what that can lead to is not being safe memory wise. And what Matt was talking earlier regarding MicroPython as well, one of the concerns of MicroPython is around memory safety. And another thing is type safety. So by type safety, what I mean is when you have got, when you declare variables in a particular language, right? So you declare your variables. So while doing that and while you're writing the code, sometimes you can get into errors, right? So it can be a compile time error, which is good because you can catch those errors at compile time. But if not, and there's no type safety checking, what it results into strange errors, like if you want an int variable, but at some later stage a function calls it and passes a string and so on, things like that. And then there's an amazing Rust CLI, which is automated, and there's a concept of binary deployment which is not available in Python today. So that is also, and that is one of the reasons why Rust is so high performance. Now, so those were the features and the good bits about Rust. It does come with its own set of challenges. The first one is a syntax. It's way harder than Python, so it won't look as beautiful, and some people even call it ugly. But then it is what it is. Some people also say that the Rust compiler is mean. So you will get errors, random errors, and things which you don't expect. It's a bit harder to write, which you don't. So and I've got millions and millions of songs, right? So essentially lyrics, which is text data, and I want to organize or make it better. I want to search through that lyrics. I want to make more money. I want to connect to singers, whatever, or even general public and things like that. So I want to sort and make my data better. So for example, let's say we have got SQL database, right, and where the data is essentially stored. And what you want to do is you want to label. So say for example, picking one of the libraries, that would be Hugging Face, which is one of the most popular libraries for these kind of problems. And it's a zero shot problem. So you may want to have a zero shot candidate. So a finite list of labels that you want to classify your lyrics. So pop, rock, hip hop, country, Latin, and a finite list essentially. So you can have two choices. You can either download a pre-trained LLM and then do some fine-tuning on top of that, or you can just train your own. Either way, you get a classification LLM. The end goal is to reach the bottom part, which is essentially to clarify your lyrics, classify your lyrics.txt and give it a score. Let's say percentages of possibilities of which label it applies to. So that's a classification problem, a machine learning classification problem. And you want to transcribe, right? So you want to do it in transcripts. And then you are doing it for millions of songs. So what happens is, it's fine when it's at a certain scale, but eventually what you'll see as you grow more and more in scale, at some stage you're going to hit a limit. And that limit could be because of performance, because of memory leakage, memory issue. It can also be straight because of cost, right? Because if you're, running these on your GPUs are very expensive. They are getting cheaper day by day, so are the services, but still they are costly enough to become, a limitation for you, right? So performance matters in trust for MLOps. So you're looking at improvement in inference performance, right? So in your scoring pipelines, you are looking at improvement into your multi-threaded performance. So there's a lot of possibilities over there, and you're also looking at your CPU or GPU performance as well. So there are different areas in this, in this GenAI project where you can look at improving that and replacing Python code with Rust. And there are many tools to do that, right? You can write some of the code in Copilot, Rust, the cargo compiler, you can use that. There are new libraries now. So there's a library Rust-Bert, and then other libraries like Organizer. So multi-threaded, computationally more efficient, memory optimized, cheaper, and safer. So all these things can be achieved in Rust. Now finally, what are the possibilities of combining Python and Rust together? So there has been quite a few projects in which people have experimented with, getting these two languages together. So it's not a matter of completely removing Python and replacing it with Rust. It's rather a matter of understanding which part are better suited to which language. So I'll go through an example. So Rust, it's known for performance and memory safety, so it can significantly speed up execution of computationally expensive parts of your AI pipeline, and that's up to you. How do you recognize which are the computationally expensive parts of the pipeline? And when you're writing the pipeline, if you have that in mind, then you will write your pipeline in such a way that you can make blocks or out of it, separate it out, and then you can just write interfaces and connect things like that. So the idea is, now generally this could be the case, right? So sometimes you have a green project, you're writing something from scratch, but most of the time you're dealing with legacy code, right? So somebody a few years ago, they have already created a project, they've written a project at a company, and you go in there and you have got an existing project, right? So what you can do best is you can rewrite some part of the code, and those will be some critical sections of the code, and that Python code base you can replace, you can understand, you can first identify that these are your performance bottlenecks, and then you can replace that with Rust. So that's what I was talking about. So creating Rust interface, and there are quite a few libraries now to do that. So there's no need to sacrifice Python altogether. There are some very good things about Python. The development speed. So that's not the speed of how it runs, but rather how fast a developer can write the code, and that is going to be way better in Python than Rust. And flexibility provided by Python, right? So all the benefits that comes for developer experience, you keep those parts, the good parts as is, and then remove these specific bottlenecks. One example could be a data processing steps, right? So this example talks about a complex operation on large images, right? So generally you would have a data processing step, right, in which you are trying to identify boundaries, right? So you do that, and when you get an image, you do bounding box, right? So all those are very computationally expensive steps of your long pipeline. So those are the ones that you can target, and then you can re-implement that code into Rust, taking advantage of how Rust makes things efficient, optimizes memory, and adds the concurrency features, right, to processes images faster and in parallel. The Rust code can be exposed to Python. No, so you have replaced it now, right? So then you have to do the connection, right? So there's a concept of foreign function interfaces, right? So you can do that, and you can build interfaces in which you can call Rust code from Python. So generally, we do that a lot with other applications as well, right? So generally, when we write Python code and we are working on some, let's say, device management, we write some scripts in C++, and then we make function calls, right? So languages can talk among each other, basically. And it can be like native Python functions. Hallucinations, which you may have heard in GenAI space, and people are talking a lot about it now. So it is one of the problems in Gen AI. Gen AI models, essentially. So, take for example, LLM models. So, one of the ways to deal with that, to handle them better, is implementing Rust to do that, which Python is not so well equipped to do that. The way forward, lots of libraries. We are slowly gaining traction. 503, Rust Python CLI project, and like I mentioned before, the binary deployment part of Rust, which is a very attractive feature. A few more examples for Rust Python binding. So that's a PyTorch binding. So there's a binding that's available in PyTorch community for Rust, which people are talking like it's really good. There's a Hugging Face candle, which is another project. There is Polars, which is similar to Pandas. So Pandas, if you use that for processing, right, data processing in Python. There's that another project, Polars, which you can replace, Pandas with. And there's a Cargo Lambda, there's another library called Cloud. So yeah, there you go. That's the end of my talk. Any questions?
I have a question about the zero-shot classification. So, why you do the zero-shot classification? I think it's quite challenging. So, because of I think the part work or the types of musics you can get the data from that side and train the model. Or why you do the zero-shot classification here?
Well, zero-shot classification is one of the examples that I gave, not necessarily going into what the problem was. Like, you can have any of the generative AI examples, right? So that was one of the examples. Yes, of course, you have several ways of coming to a solution to a problem. But the idea behind that example was to show which part can be replaced with Rust. So where in the concept of performance come in, where in the concept of memory management comes in, and how you can do that, and the libraries that are available now for you to experiment with that. There are many ways to do that. You don't have to necessarily do a zero-shot classification for a problem.
This is quite challenging because one of my research direction is about zero-shot classification. So
yes, it's challenging. Do it. Pick up another solution, I would say.
Thank you.
Thanks.
Hi. So, talked about these foreign these interfaces between languages, right? Is it the case that, because then you also talked about how Rust has these binaries, right? You can easily do that. Does this mean that if you write your code with the right sort of interface that you can take Python code within Rust and make binaries, or is it like how do these interfaces end up fitting together on a practical level? Like, do they not just have the problems of two different implementations?
Two different implementation, I would say no. But how I visualize it, like you said, you want to see how it's actually happening practically, right? The example of creating a binary, right? So, say for example, you have got a machine learning pipeline, right? And at the end of it's a serving pipeline, it's an inference pipeline. At the end of it, you have to deploy a model somewhere, right? That model generally what it is like. Generally, you would have a Python file, right? Yes. Or what is the result of an inference pipeline, right? It is it has to be an executable that has to run in some other system. Now, you're lucky it will be your own system, right? So you know the system, right? You have tested this system more thoroughly, right? But sometimes it's not, right? Sometimes they can be, foreign systems as well. So what I mean is when you're deploying your model to production, it can go into different external systems. The idea of binary is to make it more seamless and more portable. So Rust will come into play when you're doing that particular step. So you can write your code, you can start with a notebook, write all your Python stuff, do analysis and all that, draw graphs and things like that. But finally, when it comes to, after training the model, you want to deploy it somewhere, right? That is where you call Rust. You call Rust function, and that's the interface that I was talking about. So there are FT and other things that you can use to do that. But the end goal is to get to a binary which is more easily deployable and portable to other systems.
Makes sense. Just to make sure I understand, this means that you still need all the stuff for implementing Python,
Oh,
and
yes.
you need the place to put binaries in Rust, but it's still going to be more efficient.
Oh yes, that's what the last slide was about. So it's how can you marry these two, not necessarily replacing it altogether, but take the good parts of both the languages in your pipeline.
Well, I guess you get the example of the example with the images.
Yes.
But I'm just wondering like what is more effective or what is more expensive? Because obviously you talked about Python, you mentioned that it's computationally expensive. But with cloud services, like for instance, AWS, you can actually access community services like, either like, in-house or like contractors to label the data for you.
Yes.
So from your experience, what is more expensive?
So let me get your question. So you're asking about labeling of data, whether that operation / step is more expensive compared to?
So in your example specifically, you talked about image classification,
Image
right?
classification, right?
Yeah. But most of the time, you mentioned that most of the work is being done for like labeling the images and,
Oh yes.
drawing all the, but in Amazon, for instance, you can ask community or contractors to basically do that for you. So I'm asking, what is the preference from your point of view? Is it more like depending on community services, or is it like, or you prefer Python for that case?
Prefer Python for that. So one example will be using Mechanical Turk for AWS, right?
Yes.
Okay. There are two different things that I'm seeing. So you're talking about labeling data, which is the first before you actually train your model, right? So for training your model, you need label data, right? So if you've got a finite amount of, let's say, images to start off with, you can do that. You can go to AWS and there are developers who do that, right? You can pay them, and they can label your data, right? So that's the human in loop that you are introducing, and that's a good thing to do. But generally, what you're faced with is if you've got a large amount of data that you are working with, right? So labeling is a whole another world. Labeling is a problem, and then there are combinations in labeling that people use. There are semi-automatic labeling also that can be done to counter the problem that if it becomes very expensive, doing getting a human in loop every single time, you can do that. You can have another machine learning model at your labeling stage, right? At your labeling stage, and the purpose of that model will be to label. But then that is the first part of your pipeline, right? You're still not there at the training stage yet, right? And then the training pipeline will take that label data and will train itself, and then it will be ready for inference based on how good the labeling stage was, right? Does that answer your question?
Yeah.
Rust is a standalone programming language or it's a set of libraries?
There are libraries for Rust, and there are newer libraries also for Rust, specifically for GenAI machine learning. And now people are also writing libraries, NLP libraries, say for example, right? That can support Rust. But Rust is a language.
No.
Rust is a language. You write one language, somebody invents it, and then more people, they go about writing libraries.
Okay.
On
We can write our own libraries in the Rust.
Oh yes.
Yes. And we can use those libraries in Python. Call those libraries in Python.
Yes. Yes, we can do that. Yeah.
I just have a question. How does Rust better handle hallucinations?
So from what I understand, it has to do with the concept of runtime errors, right? So the way that Rust is written and the way that interacts with compilers is very different from what would happen if you do it with Python, right? So Python is still far away from how well it can talk to compilers. So there can be less runtime errors. So that is how you can eventually deal with the concept of hallucination and getting the wrong answers for a particular machine learning model that you have, right?
So does a hallucination result in a runtime error in Python?
Sometimes, yes.
Okay.
Anyone else have a question? Yep.
Hey Brady, I know you probably know the answer to this because we used to work together. When you're running like a data science team, they're probably going to be sort of using Python and maybe have an interest in Rust, but not really know how to use it and kind of get ML ops or data engineers to help out. So how do you kind of work with data science teams to sort of package up their solutions, get it into Rust for performance, but then they've got to change their models and iterate and then sort of back and forth between the two? How do you keep that efficiency of like continuous, delivery of new features?
That's a good question. So your question is, how do I introduce Rust in a pipeline where a data science team is already working on a few projects?
Yeah, and how do you sort of
MLOps,
get sort of all the changes that you might have to go back and forth between the engineers and the data science team?
So I would, how I would approach this is doing a very simple, introducing Rust to a team of data scientists, right? So how I would go about is just proof of concept, like you would do with anything new that you want to learn. Because what I'm talking about is replacing some parts of the pipeline, right? So, one good idea is to just take one of the projects, maybe which is not in production exactly, but some of the, generally teams have, project with that just for testing. And then you first recognize, take a good problem, recognize your performance bottleneck. So you have to find a problem first, right? Before you attack that problem, and then you want to implement your solution for Rust there, right? So that can be one of the ways to do that. So for example, in our projects, we have a few pipelines which are very, very slow. So how I would go about doing that is, and we have problems around data processing, right? So sometimes the data processing part of the pipeline becomes painfully slow. So I'd look at introducing Rust libraries, just kind of exploring which libraries can fit in, and if I can write interfaces and then call Rust code from Python, because my code is already in Python, that's legacy code, right? And I'm expecting a lot of problems, integration problems and other kinds of unknown problems as well. But yeah, that's how I would do it.
Yeah, there was a question over here.
Thanks for your talk. Just along the same exact lines as that, but looking from a business perspective, what examples do you have of like percentage of time reduced in those long pipelines, or clearly there's an investment required to get training and those sort of things, and there are, as you say, polar interfaces and stuff like that.
So the experiments that I have done locally, in my personal project, they have some numbers, but those numbers are difficult to confirm. But from what I've read of how people are doing it, and they are publishing, like you can go on GitHub and look at the numbers, people are actually claiming the performance benefit to go up to 70%, which is quite a lot. So that's one number. And so maybe your question is around how to, from a business perspective, you're asking, right? If I want to introduce Rust, how do I go about convincing stakeholders? Was that your question? Yes. So one way is to give them data. So accomplished projects which have moved, and especially the ones which have migrated to Rust. The big tech, Facebook, Google, they all have their forums now for Rust, and their open source community as well. So that's also a good place to start to convince your stakeholders. And then you will need something as proof, right? So that would be your initial proof of concept. If you successfully then you can have that negotiation discussion with your stakeholder. Hey, can I try Rust for this project or something, things like that.
All right, there was a question over here.
Yeah, thanks for the talk. I just have a question regarding the process point of view of building applications. So do you see the applications being built first in Python and take advantage of the faster development times? And then where you see shortfalls, then it will be optimized by Rust? Or in the future, do you see these applications being built in Rust from scratch? Like where do you see this go?
I do not see applications which are written entirely in Rust for a very long time. There will be a certain section of the developer community which would prefer doing that. But Rust is not that intuitive. And if you really look at the numbers, if you look at the machine learning community, a lot of developers and data scientists, they come from non-software engineering backgrounds. So if you take that factor, and that's a very big factor, right? You're looking at, because half of the time what I'm doing is I'm helping the data scientists write software code, right? So I'm adding this one more problem, right? So I would, and I would not advise doing that, right? So not moving away from the good bits of Python. So when you start your EDA, right, you want to take some data set and you want to, build some charts, you want to convince your stakeholder for creating a new use case, you continue to do that in Python. It will be faster. POCs, they need to be very fast, right? So iteration, so it should, bring down your iteration time. But while you're starting to build your pipeline, you need to have production first mindset, right? So from there, you start writing bits of the code in Rust, which from experience that can become performance bottlenecks. So that's one of the ways to do that.
Thank you.
We're going to call for time for questions. I'd like to thank you for the presentation. Just a quick note, if you see any glasses or rubbish or anything like that, please pick it up and take it with you or put it in the kitchen. It would be very much appreciated.
Thank you, everyone. Cheers.
Thanks, Paridhi, for that really great presentation. So now we're gonna move on to the closing of the evening, but yeah, we're gonna go into the exciting section, which is basically putting in the raffle results. So we're just gonna do a raffle directly here, and let's see. All right, so as you can see, we have a wheel here. So yeah, pretty much we're just gonna spin the wheel and we're gonna pick out 3 people. All right, so let's go with spin number 1. All right, so Jess gets the first one. Is there a Jess here? Great, so come see us after this. And let's see who's the second lucky person. All right, it's Ross. Do we have a Ross here? Oh, great. All right, come see us after this as well. And last one. Let's see. All right, Kunshan, third lucky person. Congrats. All right, so that concludes that section of things. So yeah, pretty much we're just gonna move on to closing now. So again, just a few closing notes. Thank you again, everyone, for coming here. And as mentioned before, if you want to stay updated with what's happening, stay updated with events, and express interest in speaking or in volunteering, our Slack channel is a one-stop solution. So feel free to, again, scan the QR code if you haven't yet to be able to join the Slack channel to be able to join channels, get into conversations, and pretty much that's really about it for me. And do you have anything else to add, guys?
No, just that we are kind of over time. The doors were supposed to be closed already. So just kind of not hang around too long, that would be amazing. Otherwise, we're going to lose our venue and we'll stop running outside.
That's right, yeah. So just a quick note, if anyone is interested in speaking or volunteering, please do approach either of us to talk about it, and we're happy to pretty much guide you through the process. Again, thank you everyone for coming over, and we look forward to seeing you soon again.